Muy buenos días, estimados hermanos y amigos. Una vez más estamos aquí con ustedes con deseo de saludarles en el nombre admirable, nombre glorioso, nombre sublime, el nombre de nuestro gran Dios y Salvador Jesucristo, el Señor. Esto es Sembrando con Fe y Esperanza. Bienvenidos.
Evidence That Demands a Verdict by Josh McDowell and Sean McDowell, Ph.D., continued, Disc 3. 3. Naturalism. The worldview of naturalism has a long and storied past. Ancient Greek philosophy, the seedbed of modern Western philosophy, witnessed influential thinkers who operated from a naturalistic perspective. Thinkers such as Democritus and Epicurus still wield significant influence for those who attempt to construct a view of the world devoid of the supernatural. Relative to its long history, however, naturalism's role as a formidable challenge to Christianity is fairly recent. As the Enlightenment emphasized human reason over divine revelation, philosophers, theologians, and scientists increasingly appealed to naturalism as a more satisfactory and sufficient explanation of the universe. These historical and philosophical movements resulted in naturalism's omnipresence throughout Western culture. We see it wherever clergy or professors of religion explain the miracles of Jesus as crowd psychology. We hear it whenever a PBS nature program credits nature for some remarkable wonder like the March of the Penguins, rather than God. We see it when psychologists, ignoring that we are fallen beings created in the image of God, claim that we lie or cheat on our spouses because our supposed cave ancestors transmitted lying or cheating genes to us. A. Defining naturalism. Naturalism is a nuanced term, and many use it ambiguously, referring both to how we practice science and how we use it as a worldview. Such ambiguity might give the impression that the scientific endeavor itself is at odds with faith. That idea assumes that science is atheistic in its methodology and resulting knowledge. The Christian, however, need not conflate the scientific endeavor with naturalism as a worldview. As we saw in the introduction in the beginning of this book, the scientific revolution emerged as a culture shaped by a Christian worldview. And in fact, some of the greatest scientific pioneers believed that design could be detected throughout nature. Philosopher Stephen Meyer explains, "As I studied the history of science, I soon discovered, however, that many of these scientists did not just assume or assert by faith that the universe had been designed. They also argued for their hypothesis based on discoveries in their disciplines. Johannes Kepler perceived intelligent design in the mathematical precision of planetary motion and the three laws he discovered that describe that motion. Other scientists perceived design in many of the structures or features of the natural world upon which the laws of nature operated. Louis Agassiz, the leading American naturalist of the 19th century, for whom Agassiz Chair is named at Harvard, believed that the patterns of appearance in the fossil record pointed unmistakably to design. Carl Linnaeus argued for design based upon the ease with which plants and animals fell into an orderly groups within groups system of classification. Robert Boyle insisted that the intricate clock-like regularity of many physical mechanisms suggested the activity of a most intelligent and designing agent. Newton in particular was noteworthy in this regard. He made specific design arguments based upon discoveries in physics, biology, and astronomy. B. Metaphysical naturalism. Philosophers and apologists J.P. Moreland and William Lane Craig provide a helpful definition of metaphysical naturalism. The term naturalism has many different meanings, but a standard use of the term defines it as the view that the material universe alone exists. Since most current forms of naturalism are physicalist in flavor, naturalism has come to mean that reality is exhausted by the spatio-temporal world of physical objects accessible in some way to the senses and embraced by our best scientific theories. By the universe, Moreland and Craig mean physical objects that are in some way accessible to the senses and scientific investigation. Thus, the universe includes individual things like rocks, atoms, rivers, flashes of lightning, and processes like osmosis. Physicist Stephen Barr says that naturalism is the view that nothing exists except matter and that everything in the world must therefore be the result of the strict mathematical laws of physics and blind chance. 3 important conclusions follow from metaphysical naturalism. 1. No immaterial entities exist such as souls, morals, purposes, minds, angels, and God. Since these objects are not physical, the consistent naturalist concludes that they do not exist. 2. Scientific investigation becomes the primary, or sole, means of gaining knowledge about the world. According to philosopher John Calburn, scientism is the view that only scientific knowledge is valid, that science can explain and do everything, and that nothing else can explain or do anything. It is the belief that science and reason, or scientific and rational, are coextensive terms. 3. Naturalism shapes how people live. Philosopher Alvin Plantinga explains, naturalism, isn't clearly a religion. The term religion is vague, and naturalism falls into the vague area of its application. Still, naturalism plays many of the same roles as a religion. In particular, it gives answers to the great human questions. Is there such a person as God? How should we live? Can we look forward to life after death? What is our place in the universe? How are we related to other creatures? Naturalism gives answers here. There is no God, and it makes no sense to hope for life after death. As to our place in the grand scheme of things, we human beings are just another animal with a peculiar way of making a living. Naturalism isn't clearly a religion, but since it plays some of the same roles as a religion, we could properly call it a quasi-religion. C. Science versus metaphysical naturalism. Metaphysical naturalism in Western culture has posed a significant challenge to Christianity. Because of its appeal to science, both Christians and non-Christians alike have often conflated the discipline of science with metaphysical naturalism. As a result, many well-meaning Christians have unnecessarily viewed science as hostile to the Christian faith. For such believers, science and the Christian faith are diametrically opposed to each other. If viewed properly, however, that is, if science is held distinct from the worldview of metaphysical naturalism, then science can be of significant service to Christianity, explaining the many wonders of God's creation, demonstrating the orderliness of the universe, and confirming the truth of Scripture. On the other hand, metaphysical naturalism is directly opposed to Christianity because it denies the existence of the supernatural. As a worldview, metaphysical naturalism fails to make sense of certain features of the universe. In the next section, we consider 6 characteristics of the world that resist a naturalistic explanation, but which fit seamlessly within theism: the origin of the universe, the fine-tuning of the universe, the origin of life, consciousness, free will, and morality. We will see that these 6 features of the world provide good reason to believe we live in a theistic universe. 4. Evidence for theism. A. The origin of the universe. Up until the 20th century, we had no scientific means to judge whether the universe was eternal or had a beginning. Atheists claimed the universe alone was eternal, which would have meant it was largely static and uniform. Theists countered that God is the ultimate cause of the world and that He alone is infinite and eternal. But this began to change in the early part of the 20th century, when Einstein developed his general theory of relativity. Einstein's equations suggested that the universe was not static, but that it was either expanding or contracting. An expanding universe, measured by Hubble in 1929, coupled with general relativity, strongly implies that the universe began to exist at some point in the past. After Einstein, others have discovered additional powerful evidence that the universe had a beginning. This has brought newfound support for an argument known as the Kalam cosmological argument, popularized today by philosopher William Lane Craig. It has 3 premises. 1. Everything that begins to exist has a cause. 2. The universe began to exist. 3. Therefore, the universe has a cause. Craig has ably defended each of these premises. As for the first premise, Craig says, first and foremost, it's rooted in the metaphysical intuition that something cannot come into being from nothing. To suggest that things could just pop into being uncaused out of nothing is to quit doing serious metaphysics and to resort to magic. Second, if things really could come into being uncaused out of nothing, then it becomes inexplicable why just anything and everything do not come into existence uncaused from nothing. Finally, the first premise is constantly confirmed in our experience. Critics of this argument often respond to the first premise by asking, "What caused God?" But this misconstrues the argument. The first premise does not say that everything needs a cause, but whatever begins to exist has a cause. Since God did not begin to exist, he does not need a cause. This criticism also commits the category fallacy, in which things from one category are incorrectly applied to another. For instance, it would be a category mistake to ask, "What does the color red smell like?" or "How much does the musical note C weigh?" Colors and smells, as well as musical notes and weight, are different categories. Similarly, it is a mistake to ask, "What caused God?" because by definition, God is uncaused. God could not be caused and still be God. Asking what caused God is essentially asking a nonsense question, namely, what caused the uncaused creator of the universe? Additionally, even critics recognize that the universe beginning to exist requires something uncaused. While denying a personal loving God, they usually argue that the laws of physics just exist, and given the laws of physics, the universe inevitably pops into existence. As for the second premise, Craig offers both philosophical and scientific arguments. As to scientific arguments, he points to the evidence from the second law of thermodynamics, the success of the standard cosmological model, which implies an expanding universe, and the failure of other cosmological models such as the steady-state theory and oscillating models. Even vacuum fluctuation models, string scenarios, and multiverse models don't avoid a beginning. However, a final answer to the question will require the right quantum gravity model. He concludes, "The history of 20th century cosmogony has, in one sense, been a series of failed attempts to craft acceptable non-standard models of the expanding universe in such a way as to avert the absolute beginning predicted by the standard model." As for the philosophical support of the second premise, Jonathan Morrow and I, Sean, put one of the arguments this way. Imagine you went for a walk in the park and stumbled across someone proclaiming aloud, 5, 4, 3, 2, 1. There, I finally finished. I just counted down from infinity. What would be your initial thought? Would you wonder how long the person had been counting? Probably not. More likely, you would be in utter disbelief. Why? Because you know that such a task cannot be done. Just as it's impossible to count up to infinity from the present moment, it's equally impossible to count down from infinity to the present moment. Counting to infinity is impossible because there is always at least one more number to count. In fact, every time you count a number, you still have infinite more to go, and thus get no closer to your goal. Similarly, counting down from infinity to the present moment is equally impossible. Such a task can't even get started. Any point you pick in the past to begin, no matter how remote, would always require at least one more number to count before you could start there. Any beginning point would require an infinite number of previous points. Here's the bottom line. We could never get to the present moment if we had to cross an actual infinite number of moments in the past. Yet, since the present moment is real, it must have been preceded by a finite past that includes a beginning or first event. Therefore, the universe had a beginning. The reality that the universe had a beginning brings us to the question of cause, the third premise. Flew puts this finding into perspective. When I first met the Big Bang Theory as an atheist, it seemed to me the theory made a big difference because it suggested that the universe had a beginning and that the first sentence in Genesis, "In the beginning God created the heavens and the earth," was related to an event in the universe. As long as the universe could be comfortably thought to be not only without end but also without beginning, it remained easy to see its existence and its most fundamental features as brute facts. And if there had been no reason to think the universe had a beginning, there would be no need to postulate something else that produced the whole thing. But the Big Bang Theory changed all that. If the universe had a beginning, it becomes entirely sensible, almost inevitable, to ask what produced this beginning. Even if this argument succeeds, it still does not get us all the way to the Christian God. The Kalam argument cannot demonstrate that the Bible is reliable, that Jesus is God, or that Christianity is true. It reveals only that the universe was made and that someone made it. In short, that metaphysical naturalism does not fully account for the universe. Further, though, the Kalam argument helps narrow the range of possible causes to a non-physical, spaceless, timeless, changeless, and powerful being. William Lane Craig and James Sinclair conclude, "The first premise of the Kalam cosmological argument is obviously more plausibly true than its contradictory. Similarly, in light of both philosophical argument and scientific evidence, its second premise, although more controversial, is again more plausibly true than its negation. The conclusion of the argument involves no demonstrable incoherence and, when subjected to conceptual analysis, is rich in theological implications. On the basis of the Kalam cosmological argument, it is therefore plausible that an uncaused, personal creator of the universe exists who, sans the universe, is beginningless, changeless, immaterial, timeless, spaceless, and enormously powerful." To be sure, debates continue about the efficacy of the Kalam cosmological argument. But the argument provides a significant challenge to naturalism and positive support that we live in a theistic universe. Philosopher and mathematician David Berlinski, a secular Jew, concludes, "The universe has not proceeded from everlasting to everlasting. The cosmological beginning may be obscure, but the universe is finite in time. This is something that until the 20th century was not known. When it became known, it astonished the community of physicists and everyone else. If nothing else, the facts of Big Bang cosmology indicate that one objection to the argument that Thomas Aquinas offered is empirically unfounded. Causes in nature do come to an end. If science has shown that God does not exist, it has not been by appealing to Big Bang cosmology. The hypothesis of God's existence and the facts of contemporary cosmology are consistent." B. A fine-tuned universe. One of the most remarkable scientific findings of the 20th century is the delicate fine-tuning of the laws that govern the universe, which enable the emergence and sustenance of intelligent life. Like the scientific confirmation of the beginning of the universe, fine-tuning poses a significant challenge to naturalism. Scientists have been struck by how precisely the laws of physics seem to be calibrated for life. There are many such examples of the universe's life-friendly properties, says science and nature writer Tim Folger in Discover magazine. So many, in fact, that physicists can't dismiss them all as mere accidents. British astronomer Fred Hoyle remarked, "A common-sense interpretation of the facts suggests that a superintelligent has monkeyed with physics as well as chemistry and biology, and that there are no blind forces worth speaking about in nature." Let's consider some examples. 1. The right kind of dimensions in space and time. Often, space and time are taken for granted. We live in a 3+1 universe, 3 large spatial dimensions plus 1 time dimension. But scientists recognize that the actual number of dimensions can be fluid. They even contend that our universe contains many extremely small spatial dimensions. However, if those tiny dimensions had grown like the 3 large spatial ones, no life could exist. Fewer than 3 spatial dimensions would prohibit the complexity that life requires, but more than 3 would result in no stable atoms or planets. More or fewer than 1 time dimension would remove the predictable, reliable order to the universe that life demands. Only a 3+1 dimensional universe permits life. 2. The right kind of space. The universe must expand at the proper rate in order for life's components, atoms, stars, planets, etc., to form. The initial expansion rate, mass energy density, and dark energy, also called the cosmological constant or space energy density, all affect the expansion rate. The gravitational attraction of the mass energy density results in a slowing of the expansion. The dark energy causes the universe to expand more rapidly, and the larger the universe gets, the more the dark energy accelerates the expansion. The mass-energy density contributed the greatest influence earlier in the universe, but dark energy dominates today. The amount of dark energy measured by astronomers falls far below the value expected by scientists, by a factor of 10 to the 120th. Imagine dropping millions of planets into a very large pool of water. The expected result would be planet-sized waves. If the surface measured flat down to the atomic level, that would be 10 to the 16th times smaller than expected. Not only is the dark energy minuscule compared to its expected value, only a small range of values permit a universe with atoms, planets, and stars. 3. The fundamental forces of nature. Each of the 4 fundamental forces of nature had to be carefully fine-tuned for life: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. In particular, the ratio of the electromagnetic force to the gravitational force must be delicately balanced to 1 part in 10 to the 40th. That is, 1 part in 10, 000, 000, 000, 000, 000, 000, 000, 000, 000, 000, 000, 000, 000, 000. If the ratio varied even slightly, then our universe would not have small and large stars, which are both necessary for a planet to sustain life. Large stars produced most of the elements heavier than helium. These stars burn rapidly and end with explosions that scatter the heavier elements into the galaxy for incorporation into future stars. Smaller stars, like the Sun, burn much longer, providing the stability that a life-supporting planet requires. How delicate a balance is this? Imagine covering 1 billion continents the size of North America with coins. Stack the coins in columns that reach to the moon. Paint 1 coin red and place it in one of the columns. Blindfold a friend and have her attempt to pick it out. The odds are roughly 1 in 10 to the 40th that she will. 4. Rare conditions on Earth. Recent scientific discoveries confirm that Earth has extremely rare conditions that allow it to support life. The vast majority of the universe is uninhabitable. Let's briefly consider a few. Life must be in the right type of galaxy. Of the 3 types of galaxies, only spiral galaxies with the right mass, like the Milky Way, can support life. Life must be in the right location in the galaxy. We are situated in just the right place in the Milky Way to avoid harmful radiation. Life must have the right type of star. While most stars are too large, too luminous, or too unstable to support life, our Sun is just the right size and age. There is a window of time in which a sun can support complex life. It can't be too young or too old. Life must have the right relationship to its host star. If Earth were slightly closer to or farther from the Sun, water would either freeze or evaporate, rendering Earth uninhabitable for complex life. Life needs surrounding planets for protection. A habitable planet must have large surrounding bodies such as Jupiter and Saturn. The early motions of Jupiter and Saturn removed most of the asteroids and comets from the solar system with 2 beneficial effects. First, the removal process also caused many collisions early in Earth's history. These collisions added water, ammonia, and other life-essential materials to Earth. Second, the loss of comets and asteroids reduced the subsequent rate of impacts on Earth by a factor of 1,000. Life requires the right type of moon. If Earth did not have a moon of the right size and distance, it would be uninhabitable. The moon stabilizes the Earth's tilt, preventing extreme temperatures and thus creating a stable, life-friendly environment. What happens when we try to assign a probability to the fine-tuning of all the known constants of nature? Theoretical physicist Lee Smolin calculates a much smaller number, the probability of a universe where stars exist. Perhaps, before going further, we should ask just how probable is it that a universe created by randomly choosing the parameters will contain stars? Given what we have already said, it is simple to estimate this probability. For readers who are interested, the arithmetic is in the notes. The answer in round numbers comes to about 1 chance in 10 to the 229th. Stated another way, if every proton in the universe represented a universe with different laws of physics, the probability calculated by Smolin means that none of those universes would contain stars. The evidence for design is so compelling that Paul Davies, an internationally acclaimed physicist at Arizona State University, has concluded that the bio-friendly nature of our universe looks like a fix. In other words, the universe is so uniquely calibrated to support life that it seems to go beyond the reach of coincidence. He writes, "The cliché that life is balanced on a knife edge is a staggering understatement in this case. No knife in the universe could have an edge that fine." According to Davies, any legitimate scientific explanation must account for this overwhelming appearance of design.
La Iglesia Pentecostal Unida Latinoamericana en Baltimore nos estamos reuniendo en la 8301 Liberty Road, 8301 Liberty Road, Windsor Mill, Maryland 21244. Y nuestras reuniones son los días domingo a las 8 de la mañana. Domingo 8 de la mañana tenemos el servicio de adoración, alabanza y enseñanza de la palabra de Dios. Venga juntamente con su familia y allegados. Serán todos bienvenidos a nuestra reunión dominical. Recuerde, Jesucristo es el verdadero Dios y la vida eterna. Primera de Juan 5:20. Y si otros días madrugamos a buscar la comida que perece, ¿por qué no hacerlo el día domingo para buscar la comida que a vida eterna permanece? Le esperamos.